In this video we take a look at Jadx and Jadx Gui. Both of them are able to handle a whole APK file, and they can also recompile those resources, which means we get access to the Android manifest XML and the Java source code. They have of course their disadvantages, and we will compare them against the DAX to jar approach, which we have done before. But overall these two tools are amazing and should be definitely in your toolbox. Now let's start installing them, and afterwards we take a look at the parameter they provide, because some of them come super handy during our reverse engineering process. So I would say let's go, let's switch to the Ubuntu VM. Alrighty, here we are at our Ubuntu VM. Now let's start downloading and installing them. And therefore I open my web browser and I search for Jadx and GitHub, because this is a GitHub project. Then we use this from Skyload over there. And then we can use those releases, or we can simply clone the repository, which I do. So I copy paste this one and then I go into tools. And here I simply say git clone, and then we clone the whole repository. If you do not have installed Git, you can simply install it via sudo apt-get install git. And afterwards you can clone this repository. Then we get this directory over here. This one, Jadx. Gonna enlarge this a little bit. And then we say Gradle, this is the build system, and we say dist. And now it's fetching all those necessary binaries and also compiling those code which is stored inside there. This take a while, and I will come back after this process has been finished. Alrighty, here we can see build successful, so the build process has now been finished and we've got a new directory over there which is called build. Then we go into this one, into Jadx, into bin. And here we have now Jadx and Jadx Gui, and also the Windows version with the bud extension. Now we add this directory to the path variable that we can simply run Jadx and Jadx Gui from wherever terminal location we like to. Therefore, I get the directory over here and I simply extend the path variable, which we have done in the past with the Android setup or for other tools. So I open this in Vim, and here we simply append this directory, we add this colon, and now we're good to go. If we go back, then we can run Jadx command not found, because we need to refresh our ZSH environment. And now we can use Jadx. We have to provide an input file. Alright, it's working so far. So the installation process is now finished. Now let's have a look at the options of Jadx. We've got two tools. We've got Jadx and Jadx Gui. Jadx is the command line version and Jadx Gui provides a graphical user interface. But we start with the command line version. So we type H for help. So the first line tells us Jadx seems to stand for DAX to Java decompiler. Then we use Jadx by providing options and an input file, which can be an APK, a DAX, a jar, a class, a smali, zip, and some other files. We can define output directory that stores our resources and our Java sources. And as in the APK tool, we can also define do not decode resources or sources. And this might come handy if there are some errors within decoding resources or sources. We might to skip then the exact part. We can also say decompile a single class name or class file, which is also nice. Alrighty, what else do we have? Another nice feature is the deobfuscation part. So what is a deobfuscation? Let's assume we've got a class name which is main.class. And this class name now gets reduced to a single letter, for example a.class. And this class name now contains methods like b, c, d, and e. And this happens to all class files. And the algorithm needs to take care that it does not overwrite. For example, rename both classes to the same. But if this does not happen, then we end up with a bunch of jars at the end of the whole source code. So then we've got methods like a.b.c.ab.c. And this is not easy to reverse engineer. Therefore, Jadx tries to give this a little bit a better name. Of course, Jadx cannot do some magic and restore the original name, but it can try to make some recognizable patterns. And this is what Jadx does. This approach helps a little bit, but if you have to deal with a highly obfuscated app, the only thing I can imagine is debugging this application. We have a section about this later on in, where we talk about debugging an application. The next two parameters are regarding to the min and max length of this deobfuscation technique. And this also has some side effect, which I'm going to show you later on also. Alright, the last useful option might be this dot file, but I will show you a different application that handles this task, in my opinion, a little bit better. What this parameter does, it saves a call graph into a dot file. And a call graph is simply, a graph overview about the calling hierarchy of this application. So if this class opens this method and this method calls this class and this class calls this method, it shows this in a nice overview. And this is super handy because I used this once to solve a very hard reverse engineering challenge of an Android app. I'm also going to show you this approach later on in the special section. Alright. Then we've got the verbosity and some log level. For example, error is really useful to include because Jadx fails a little more often than Jadx in my opinion. And by providing this error, we can see where it fails at which class name or which resource, for example. And by having this information, we can make the decision for ourselves if we need this now decompiled or if we do not need this decompiled. If we do not need this decompiled, we can simply move on. But if this is the most important piece, then I would try different tools, for example Jadx or the special tool which I'm going to show you afterwards. And finally we've got the threads count over here, and this one is also super nice in Jadx. Because Jadx is able to multi-thread this whole decompiling process, and this comes super handy if we have to do or decompile a lots of APK or if we have to decompile a huge APK. Multi-threading means we can distribute our task to certain CPU cores. And I've also provided you within the cheat sheet a basic calculation how you can figure out how many cores you can provide to Jadx for this multi-threading part. Alright, now let's decompile our SpacePang application and take a look at the result. So I'm going into apps and we create a new directory and we name this SpacePang Jadx. And we copy paste this out from here. Okay, then I open the terminal over here and we say Jadx, then the name, and we say log level is error. I'm going to enlarge this. Now let's see. Now Jadx is creating a new directory and also processing those files. And we've got our first error within this class here. The JSON reader path seems not to be decompiled correctly. And we've also got this one over here, which is regarding to a compression class name can also not be decompiled. We get this at the end with 2 errors. Alright, 2 errors is not that bad, to be honest, for this application. Now let's have a look into these single files. Here we've got those resources and sources. If we click into the resources, we are familiar with this. This is our application structure. We've got this classes.dex, but we've got also this Android manifest XML, which is now decoded. So Jadx is able to handle those resource files. Okay, so there's nothing special in here right now. We are pretty familiar with this, but we are more interested in the Java code. And this one is over here. And now we've got the structure regarding to the package name of the Java classes. For example, we've got this one here, DE, then the name of the author, SpacePang, and here we've got now the Java source code. Let's have a look into systems, alien behavior system. And here we can see, yes, this is the decompiled Java code. And this looks pretty good so far. Okay, let's have a look at the class name that cannot be decompiled. And here we can see, okay, this one. So this one should be the class name, and it's easier to search for the class name to get this file instead of browsing through all these directories, because we have to replace those dot with slashes. Oh, I've closed this one, but it doesn't matter. So within sources, we have now to go into com and so on. But I search for this class over here. Then I'm going to open it. And here we can see, yes, we have seen this with Jadx also. So Jadx was able to handle this class and also this method, but it might fail on other classes. And therefore we can do this approach for both. So we decompile our app with Jadx and dex to char, and then we can merge those results and see who did a better job in which function, and then we can merge those results afterwards. So this is how Jadx works. Now let's have a look at Jadx Gui. Go into the apps directory back again. Space pang Jadx. Oops. And then we use Jadx Gui, and we can also provide an age, but these are the same parameters. So we can use, for example, the error method over here again, the log level error. Then we can see where Jadx Gui also could not decompile those files, but Jadx Gui does the same like Jadx, but afterwards provides a GUI for this. So that's all. Okay, then we use Jadx Gui on this file. And here we have now our editor, and this looks pretty similar to the JD Gui part, but we've got now those resource files over here and also this APK signature. So Jadx is also able to decode those resource files over here. Okay, we can now open the Android manifest XML and we can browse through this over here. And the one thing I want to show you right here is the obfuscation technique. So let's see. Now we've got those class name, and this one is an interface with the capital I over here. You can see this here. And if you click on this symbol here, which is the deobfuscation, it tries to deobfuscate this application, but we can see this app has not been obfuscated. But I still hit this button right now. And now we can see something has been changed. We can see DE got 2 letters, and if we hit the deobfuscation button, the program thinks this one is obfuscated and tries to deobfuscate it by appending P005 in front of this. So it makes this a little bit a recognizable pattern. And this also happens for the R, which I do not found anymore. So I'm not sure where the R is right now. Therefore, if the app is not obfuscated, then you shouldn't also use this option, because you make it, I guess, worse by doing this. I now hit this button again, and we can see right now, okay, this one, I do not know where this class has been decompiled or renamed into, but I couldn't find it. Maybe I didn't extend the directory there. Oh yeah, I didn't extend the directory, therefore I couldn't find it. Sorry. Here we can see this R now gets this recognizable pattern, C0256R. Alright, and this is what the deobfuscation option does. The only thing I want to mention right here is this one. If you search for classes, variables, attributes, whatever, please use this instead of this search option, because this is only a class search and this is a text search, and here we can also define all those parameters. And at the bottom you can see that the indexing takes a while, but now we can search. And now we can see we get those fragments, which is a little bit wired. In my case, or in my opinion, the best way is to store those Java classes. You can do this with Jadx decompiling, or you can hit this button here, save all, and then you can provide a directory name and then use Eclipse to import them again. So I'm going to show you this real quick. So with Jadx, we have decompiled this one with the client version. Over here, the sources. And now we download, install Eclipse, and then create a new project and import them. So I speed this up a little bit. Okay, here we have now the project, and we simply drag and drop our directories into this source directory over there. We can also remove this one because it's not necessary. So we go into apps, spacebar Jadx, sources, and we drag and drop them over here. Copy files and folders. And now they will be all available, and we can see also a bunch of errors. This is also the reason why we cannot simply decompile this application, put them into this one and compile this app back again. Because we will end up with, we are now at 6,000 errors, and this value might even increase. Okay, after they have been imported, we can simply go to search. We click on file. We can here search for Java, but we can also use this file search over here and provide the shield parameter now right here. And then it will go through all the files. And if we do this, we can enlarge this, and here we go. We can now double click on this, and we get all those classes over there where shield appears. So I also like this approach, decompiling this app with Jadx and then loading those sources into Eclipse to reverse engineer this application. Alrighty, let's switch back to the presentation. So here we have the command line interface version of Jadx, and this comes super handy if you want to mass decompile Android apps. We can use this to load a bunch of applications into Jadx and automatically decompile them. This approach would look like this. For example, if we use an RP or if we have fetched a lot of APKs, then we can use Jadx to decompile them and store them into single directories over there. And afterwards we can browse through this and, for example, search in the Android manifest for exported content providers or exported activities, static keys, RP endpoints, and things like this. And to automate this whole process, you can use find, which is shown in this command above. So you can use find-iname to find all APKs on your system or in this directory. And then you can use exec Jadx, and you can provide those brackets, which is the APK name, and then simply use an output directory and decompile them all into this output directory. I'm going to show you this real quick because this is super nice, this feature. All right, here we are back at our Ubuntu VM. And let's see, I guess within our downloads directory, yes, we've got some APK files over here. And now we create an output directory, and then we use this find. And what find does is, it takes now all APKs in this directory, and it would also go deeper into those directories to find those APKs and decompiling them into this out directory over here. Yes, and now we are done. Let's look into the output directory, and here we have now all those source files. Yes. So we can now browse or grab through these files and search for some vulnerabilities or other stuff. Then we've got Jadx Gui, which can be used on a single application file. And we end up with decompiled resources and also with decompiled source files, which is shown over here. Finally, here's an overview about the most important parameters, but we already talked about them. All right, finally the battle between Jadx Gui and Jadx Gui. In this case, it's more like dex2jar and then Jadx Gui, because Jadx Gui is not decompiling this application. But here on the left, we can see, okay, Jadx fails a little bit more often, in my opinion, than dex2jar. And therefore, I like to use dex2jar more than Jadx. But this is my personal preference. In case of dex2jar fails, you can of course try it out with Jadx Gui and see if this might work better. And afterwards you can merge those results, and you might have got a more complete Java source code over there. Alright, that's all for now. I'm looking forward to see you in the next section where you get your task on reverse engineer this application.